We have some things to finish up in our ISN. So this is on what page, guys? 8. Okay, we had some things to finish up on 8. We already have this filled in. Okay. How about this? All right. This. Is this where we start? Okay, so this is not filled in, is what you guys are telling me. Okay. I remember us running out of some time one day. Calculate the slope. Okay, so if we're given 2 points, the first step is to calculate the slope using y2 minus y1 over x2 minus x1. That's our slope formula. All right, so if this is your x1, y1, and this is your x2, y2 points, substituting in those values, the y's I'm doing on the top, and those are your second numbers in your ordered pairs. We're doing the x values on the bottom. Those are the first numbers in your ordered pairs. So we're going to start with the 8 and the 2. And I'm coloring it. You don't have to unless you like to. So m is equal to, starting with those y's, 8 minus 2 would be on top. And negative 1 minus 5 on the bottom. That equals 6 over negative 6. And 6 divided by negative 6 is negative 1. So that would be our slope. Step 2 is use one of the points in the point slope form. The point slope form is y minus y1 equals m times x minus x1, where you're plugging in y and an x, and you're using, I'm going to use the x1, y1 point that we already labeled, and you're substituting in the slope, which is your m value of negative 1. So I'm going to plug all that stuff in here. y1 is 2, so I'll have y minus 2 equals m is a negative 1, parentheses, x minus x1 was 5. Okay, substitute those in. Now I'm going to distribute the negative 1 on the right side. Multiply this out. I get negative x plus 5, or negative 1x. If you want to write a 1 there, that's okay. The next step would be to add 2 to both sides to get it in y equals mx plus b form. So y equals negative x, and then 5 plus 2, of course, is 7. So negative x plus 7. I need to wait a bit. I can wait. Is there more on this page? 8. That would be the last thing on page 8. So now I need to find the beginning of page 9, and I kind of slipped some pages in here, so I think I have to go backwards here. We good? Is this the first page of page 9 now? Alrighty. Our slope, you can write an equation. So this is a summary. You can write an equation of a line if you're given any of the following. M, the slope, and the y-intercept, which is b. Then you would use y equals mx plus b form. You can use m, the slope, and the coordinates of one point, x1, y1. Then you would use x minus x1. Excuse me, I just started that off wrong because my brain went somewhere else for a moment. I have to fix that. I'm back. Y minus y1 equals m times x minus x1. And if you're going to have the coordinates given to you of 2 points, x1, y1, and x2, y2, that's 2 different points. You would start off first by finding the slope using y2 minus y1 over x2 minus x1. That would be step 1. And then step 2, you would substitute it into that formula right there. Okay, substitute those values into that formula. Use point slope. Oops. All right, so the only extra step when you have 2 points given is you have to find the slope using the slope formula. Then you plug one of the points in into the point slope formula. I'm going to quick look at my ISN just while everybody makes sure it gets that page finished and figure out what's the next thing on your paper. Does it say? Oh, I know. It's for some reason this is very scrambled. This is what's next on your paper, right? Okay. So slope-intercept form is y equals mx plus b. Point slope form is y minus y1 equals m times x minus x1. Example, gosh, we've got several of everything, I think, is to write an equation of a line slope-intercept form. That's y equals mx plus b. If you're given the slope, that's your m. If you're given the y-intercept, that's your b. And you just fill it in, negative 1/4 times x plus 6. Got to remember, slope does not have an x on it. It is a number. Write an equation in point slope form. That's y minus y1 equals m times x minus x1. If you have a slope of 4, that's your m. If you have a point with x1 being 2, it'd be x minus 2 over here. And the y1 is negative 1, it'd be y minus negative 1. I'm going to be returning your quizzes to you from last Thursday. I think, did we take it Thursday or Friday? Can't remember. Friday. All right. Y minus negative was Thursday. Y minus negative 1, we would need to change. I took off for this, guys. You never would leave it written minus a negative. You need to simplify that. So what should you write if you have minus a negative? Plus, yes. So you should at least do y plus 1 equals 4 times x minus 2. I took all those. But really, we should take this a step further and get it in y equals form, okay? But if it said point slope form, I could take this, right? If it says put it in y equals mx plus b form, then you might have to take it another step, which I'll show you what I mean by that. So we would need to distribute y minus 1 equals 4x minus 8. I distributed the 4 to get to this format, and now I would add 1 to both sides, and I could write the equation y equals 4 times x minus 7. That's a really good answer because you get to write this. This would be easy to graph. You'd start at negative 7 and go up 4, right 1, up 4, right 1. All right, next. Yes, Cadence? What did I do? Oh, you know what I did? Thank you. It is negative 9. Thanks for spotting that before I went on. You see how I copied it wrong? You see what I did? This was a plus. I copied that wrong over here. I should have had plus here, right? And then let me fix this. My bad. Minus. This would be minus 9. Good job. Wow, I need to be careful when I copied that over. I'll write it nicely. Please don't have a mistake in your ISN. Thank you. Fix it. Did anybody else notice that? Oh. Okay, that was what I did. Was I didn't transfer. I don't know why I wrote minus 1 instead of plus 1. My mistake. Yeah, I wrote -1 instead of +1. All right, anyway, let's move on. So then from here, we haven't got that, right? Okay. So what I would like, highlighters really help on this concept. It says identify the parallel lines. Yep, M and N. That's just the ISN. We're looking at, we're working in our Chapter 3 ISN, finishing it up. This guy here. All right, this transversal S cuts through lines M and N, which would give a relationship between these angles. All right, so the parallel lines we just identified are line M, I can write, it's not lime, line M and line N are the ones that are parallel. Now it said circle angles along non-parallel transversals, which means these guys have to do with one another. And then on the other side, you kind of like ignore those for a minute and you go to these and you say these are related. Okay, and how are they related? Well, because you have parallel lines M and N, you can figure out all the measures of these angles over here if you knew the measure of one. So here's how I'm going to show an example for you. Let's say that angle 1 was 70. What other angles would be 70? Angle 3 would be 70 because it's vertical to angle 1. Angle 9 would be 70 because it's corresponding to angle 1. Angle 11 would be 70 because it's corresponding to angle 3 or alternate exterior to angle 1. Now, the rest of the angles are not 70. What size are they on this side of this over here? 110 because they're supplementary. 180 minus 70 is 110. And these are all 110 then. Okay. So likewise on this right side, I'm not going to write all over these. I'm going to say, what if we were told that the measure of angle 5 was 120 degrees? Could you tell me the measure of angle 6? It would be supplementary, so it would be 60. The measure of angle 7, measure of angle 8, let's see. 7 would be 120, yep. 8 would be vertical with 660. Okay. Then we could go down low and hit the measure of angle 13, the measure of angle 14. Let's see what they'd be. Well, they're going to be the same as 5 and 6. Corresponding angles are congruent if the lines are parallel. So we've got 5 and 13 the same. So if 5 was 120, 13 is 120. And if 6 is 60, 14 is 60. And then the measure of angle 16 can't be 120. That's going to have to be 60. And the measure of angle 15 would be 120. Okay. I just made up some numbers to do the picture. And I'm not saying that that was to scale, all right, at all. Matter of fact, I probably should have picked lower numbers for. All right, we still have left some stuff about, that's way far off. I got to get back to where we need to be right now. And I got some erasing to do. So I accidentally put a bunch of lines in between. Where'd I go? No, I just did all that. How did I get? Perpendicular transversal theorem. So that I can make sure I'm explaining this. I don't want to just copying it. To draw this diagram though. Should be page 10, right? Top of 10 in our ISN. So what I did was I made lines A and B parallel. I cut through them transversal C. And I put a box on line A. And I showed them to be parallel by the arrows. So the point would be that if A is perpendicular, by the perpendicular transversal theorem, it says, if line A is perpendicular to line C, and line A is parallel to line B, then B must be perpendicular. Line B must be perpendicular to line C also. That's all it says. So because line A and C are perpendicular and A and B are parallel, B has to be perpendicular to C. Anybody still need this? Okay, no problem. Okay. Can I go now? All right. This is what you need to write for corresponding angles converse postulate, which says if two lines are cut by a transversal, so the corresponding angles are congruent. That means you're given that angle 2 and 6 were congruent. Then you can state that lines J and K are parallel by corresponding angles congruent implies parallel lines. If corresponding angles congruent, you can put an if here if you want. Don't have to. I'll take it without it. I would also accept the corresponding angles converse postulate, but I got a feeling you might be better off writing this. This is great. Okay, anybody still need this? No? All right, next one. Parallel postulate says if there's a line and a point not on the line, then there is one line through the point parallel to the given line. So this picture is kind of not really showing you what they're talking about. You don't have to draw anything, but let me just show you how it went. They're just saying that if you have a line L and then there's some point P out there, there's only one possible line to draw through P that would also be parallel to L. That's all. It'd have to be just that one line. You can't do it any other way. That's all it means. Okay, alternate interior angles converse says that if two lines are cut by a transversal, so the alternate interior angles are congruent, then the lines are parallel. So what I remember the Z thing. I'll just erase and show you what I did. The backwards S or Z. This is a backwards S, or this is actually an S. No, it's not. That's the Z. I get confused with that. It's either these, remember? There's your Z, or your S. There's your angles right there and there. If those happen to be congruent, then you have to have parallel lines J and K. So with alternate interior angles congruent, then you have parallel lines. Anybody need this still? Okay, another one, alternate exterior angles theorem. There is no Z or anything on that one. You simply have to know that if you have alternate exterior angles congruent, which are on the outside of the lines, on alternate sides of the transversal, then you have parallel lines. Got an illustration. All good. All right, and then consecutive interior angle converse. This one we struggle with most, so I'm going to write a couple things on here. Of course, what it says is if two lines are cut by a transversal such that the consecutive interior angles are supplementary, that's important, not congruent, then the lines are parallel. All right, so where are they? They are always on the same side of the transversal between the two lines. Okay, so when you see them on the same side there in between, those angles add up to 180. So the measure of angle 3 plus the measure of angle 5 is 180 degrees. The short version, consecutive interior angle supplementary, implies you have parallel lines. Okay? And the perpendicular transversal converse. Let me help with the picture. If two lines are perpendicular to the same line, then they are parallel. Not really much of a short version, but two lines perpendicular to the same line are parallel. I'll draw a couple of lines. Line A, line B. So if you saw a transversal cut through them, and both of those were right angles, the transversal makes right angles with lines A and with line B, then you can say that lines A and B have to be parallel. Okay, I believe next we have a little summary of the ways to prove lines parallel, which somehow I squeezed in those things. So I'll go find it. And isn't that next right there? Okay, so I'll let you copy down the 5 ways to prove parallel lines. This is again how to prove that two lines are parallel. If you flop these around, then you're proving, because you have parallel lines, some other stuff, which we did earlier. All right, I think we've had a chance to write those down in our ISN. Now we got a proof we're going to do. Okay, now let's, because we got one on the test tomorrow, right? Very similar. Line A and B are given to be parallel. Okay, so I am going to highlight that on my picture. Okay, now, we already are also told that angle 3 is congruent to angle 1. There is no special reason. Angle 1 and 3, some kids think those are alternate exteriors. They are not. They aren't alternate exteriors. Angle 1 is made by lines B and X. Angle 3 is made by lines Y and A. They have no relationship whatsoever. Okay? So it was given that they were congruent. I'm going to mark the diagram with that. Now, they have said that angle 1 is congruent to angle 2. Why can we say angle 1 and 2 are congruent? What kind are they? Corresponding. And what kind of lines are these? Parallel. So, if you have parallel, then corresponding angles are congruent. Now, it's acceptable to write the corresponding angles postulate, but I think more of you are going to remember it's not a theorem and that it's a postulate. You're going to be better off just writing parallel implies corresponding angles congruent, or corresponding angles postulate. Okay. Angle 3 is congruent to angle 2. Now, okay, we got to go back. I'm going to mark this up here because I already said it. 2 and 3 are congruent, and it's not because of alternate exterior angles, right? Do not write that. Okay, 2 and 3, because I still don't have X and Y parallel, guys. You need to use this and this together to make that. Yes, it is. I'm hoping to hear another word, though, too, because this is truly 1, 2, 2, 3, 1, 3. Even though it says 3 instead of 1. You know what I'm talking about, Chloe? Transitive. Transitive is actually the best answer, but I would accept substitution as well. Transitive property or substitution would be fine. All right, now that I have angle 2 and 3 congruent, I can state that lines X and Y are parallel. What kind of angles are 2 and 3? Only look over here. Popping over the transversal on the outside. Alternate, exterior, angles, congruent, then you get the parallel lines. All right, we were proving that lines were parallel. That's a weird congruence symbol. I have a lot of extra lines there. Okay, so alternate exterior angles congruent, then you have parallel lines. Is that our last thing? We are done finally with the ISN. The next step would be to go looking at our chapter review. I am not going to record that right now.